Welcome. Today we are going to talk about scientific notation with negative powers of 10. Again, scientific notation is a method of writing very large numbers, but also very small numbers. And negative powers of 10 represent very small numbers. So a typical human hair has a diameter of 0.0000025 meter, otherwise known as 25 millionths of a meter. Write this number in scientific notation. So remember, when we were writing the scientific notation with positives, we had the decimal that was one digit to the left of the decimal was between 1 and 9. So when we're writing this in scientific notation, we try to get it in that same situation, okay? So we're going to go through this list, and we're going to just pay attention to how the decimal point moves. We have 2.345 times 10 to the 0 power. And remember, 10 to the 0 power is the same as if it was times 1, which means it doesn't move at all, okay? 2 and 345 thousandths times 10 to the first power means that that decimal point is going to move to the right one place. And so then we get 23.45. Then we have 2.235 times 10 to the second power. That means, second power means that decimal is going to move 2 places to the right, and we're going to get 234 and 5/10. So with each increasing power of 10, it moves 1 place to the right, okay? So for this one, it's moving 1, 2, 3 places. So this one's going to be 2 and 345 thousandths times 10 to the third power, okay? Now we're going to go the other direction. We have 2 and 345 thousandths times 10 to the 0. Remember, that's the same as 1, so it doesn't change. 2 and 345 thousandths times 10 to the negative 1 means that it's going to the left one place. Opposite of positive is negative, so it stands to reason that the decimal point would move 1 place to the left. So we move it 1 place to the left, and then we add a 0 as a placeholder. We have 2 and 345 thousandths times 10 to the negative 2. This negative 2 tells me it's going to move 2 places to the left. So we're going to move it 2 places this time. We had to add a 0 because that's our placeholder, and then our decimal, and then another placeholder. So what we're noticing is that as the exponents decrease, as they go down, it moves to the left. And so it's a decreasing power of 10 moves to the left. So in this case, the decimal moves 1, 2, 3, so it's going to go a negative third power. Okay? Remember, the power is the movement of the decimal. All right, so we're going to move the decimal point in this number to the right as many places as necessary to find the number that is greater than or equal to 1 and less than 10. And what number did you find? So decimal point currently is here. It needs to be where to be scientific notation. It needs to be between two numbers, where the one on the left is between 1 and 9. So it's got to go between the 2 and the 5. So 2.5. Now, if I take that 2.5 and I divide it into the 25 millionths, so we're going to take our 25 millionths, that has 1, 2, 3, 4 zeros, 25, and divide it by 2.5, I get 1 and 1, 2, 3, So 100,000. 1 in 100,000. As a power of 10, it would be 10 to the negative 1, 2, 3, 4, 5. Combine the answers on B. So 2.5 times 10 to the negative 5th power. And there it is, 25 millionths to scientific notation at 2.5 and times 10 to the negative 5th power. When a number is between 0 and 1, use the negative exponent. So because it's 0 out here, we're going to use a negative exponent. We're going to move to the left 2 places to get to the correct location for a scientific notation number. And because we moved it 2 places to the left, it's going to be times 10 to the negative 2 power. The average size of an atom is this length across. Write the average size of an atom in scientific notation. So when I'm looking at this, I need 1 digit to the left of the decimal that is between 1 and 9. And so when I'm looking at this number, these are all zeros until I come across this 3. Now the decimal has to go behind the 3 because 3 is the number that is between 1 and 9. And then I could say 3.0 times 10, or because it's a whole number, I can just say 3 times 10, and then we had to move it 1, 2, 3, 4, 5, 6, 7, 2, 3, 5, 6, 7, 8. 8 places. So it's going to be since it was to the right, it's a negative 8. And it can be written 3 or 3.0. Either one is fine. So I'm going to write these each into scientific notation. When you look at number 4, where is the decimal going to go? It's going to go right here between the 8 and the 2. So I'm going to have 8.29 times 10 to the 1, 2, 3, 4, 5th, negative 5th power. When I look at this one, where's the decimal going to go? Between the 3 and the 0 following it. So I'm going to have 3.02 times 10 to the, how many places did it move? 1, 2, 3, 4, 5, 6, 7. So negative 7th power. On number 6, where would the decimal go? It would go here. So it's going to be 7.0 or 7 times 10 to the, how many places did that decimal move? 6 places, so it's going to be a negative 6. Sometimes we have it given to us in scientific notation, and we need to write it in standard form, which means we're going to undo what we've done. So it says platelets are one component of human blood. A typical platelet has a diameter of approximately 2 33/100 times 10 to the negative 6 meter. Write this in standard notation. So the negative 6 is telling me that it moved right 6 places. Because we're undoing it, we're going to go left 6 places. So we're going to write our 233, and the decimal starts here, and then we're going to go 6 places to the left, and that means I move 1, 2, 3, 4, 5, 6 places, decimal goes there, and then add a placeholder. So we're going to take number 9 and we're going to write it in standard form. How many places is the decimal going to move? 6 places. So we're going to write the number. It starts here between the 1 and the 0, and we need to move it 6 places to the left. So it's important to note that it's not adding 6 zeros. It's moving 6 places. So you're going to move it 1, 2, 3, 4, 5, 6. So you'll notice there's not 6 zeros between the decimal point and the first non-zero digit. Okay? If you want to add that you have 6 zeros and include the 1 on the left, that's fine. That works as long as it's in scientific notation first. Okay, let's take a look at number 10. 9 and 9/10 times 10 to the negative 5th power. The decimal is going to move which direction? Left. How many places? 5. So write down the number and move it 5 places to the left. Okay, and then we get this. Checking. 1, 2, 3, 4, 5 places. There's my decimal. And then placeholder in front. Go ahead and do number 11. Decimal is going to move left 2 places. Where is the decimal when it starts? You're right, it's right here. It's behind the 1. So go ahead and write it in standard notation. In standard notation, that would be 1/100th. If you have any questions, please see your teacher.